Have you ever just looked around? I mean, really looked at the world. From a tiny little beetle to a massive blue whale, the sheer variety of life is just mind-blowing. How did all this happen? Well, it turns out there's this elegant, powerful code that connects every single living thing. And today, we're going to unpack it.
And that's really the central puzzle, isn't it? Why are there millions upon millions of different species, but only one you? On the surface, it looks like just random chaos, but it's not. There's a hidden process, a shared code that links everything and explains exactly how all this spectacular diversity came to be.
So the guy who first started to really crack this puzzle, you've heard of him, Charles Darwin. He saw clues everywhere he looked. He saw it in the beaks of finches, each one perfectly shaped for the kind of food it ate. We see it in the crazy variety of our dogs. I mean, a Great Dane and a Chihuahua both came from the same ancestor. The key to understanding all of this is that the entire grand process starts with tiny, random changes.
So, where does all this variety actually come from? To really get evolution, we have to start at the very beginning, with the raw material, the fuel for the engine of all this change.
It all begins with something called a mutation. Now, don't let the word scare you. You can just think of it like a random typo in the genetic code, the book of life. Most of these little typos are totally harmless. Some can even be bad. But every now and then, one creates a brand new trait.
And here's why that is so important. These mutations, they create variation. You know, all the little differences between individuals. Without this constant shuffling of the genetic deck, evolution would just grind to a halt. It would have no new cards to play. Variation is the absolute essential fuel for the journey. Okay, so we've got all this random variation just floating around, but that just sounds like a mess, right? How do you get from random typos to creatures so perfectly suited to their worlds? Well, that's where the core mechanism of evolution comes in. It's a process that works a lot like nature's very own sorting hat.
This is what Darwin called the struggle for existence. And it's a good name for it, because life is competitive. There's just not enough food, space, or mates to go around for everybody. So individuals are always competing. And let's be honest, not everyone makes it. And this sorting process comes in two main flavors. On the left, you have natural selection. The driver here? The environment itself. The only goal is survival and reproduction. Simple as that. Now, look at the right. Artificial selection. Who's the driver here? Yep, it's us, humans. Our goal isn't just survival, we're breeding for specific traits we like, whether it's the fastest horse or the sweetest corn. And this is a perfect example of how it works in the wild. Take the peppered moth. So most of them were light-colored, which was great for hiding on light-colored trees. But then, the Industrial Revolution happened. Factories covered the trees in dark soot. Suddenly, being a light moth was a death sentence. You stick out like a sore thumb to hungry birds. But the few moths that happened to have a dark color mutation, they were camouflaged. They survived, had more dark-colored babies, and boom, over time, the entire moth population evolved to be darker.
So what happens when this process repeats not for a few years, but for thousands or even millions of years? It crafts these absolutely incredible traits that give organisms an edge. These traits become their blueprint for survival.
We call these amazing traits adaptations. Now, an adaptation isn't something an animal learns. It's an inherited characteristic, something passed down in the genes that makes an organism a better fit for where it lives. It's basically the grand prize for winning the game of natural selection, generation after generation.
And adaptations come in three main flavors. You've got your structural ones, physical features, like the thick, warm fur on a polar bear. Then there are behavioral ones, things animals just know how to do, like birds flying south for the winter. And finally, there are physiological adaptations. That's the internal stuff, like a camel's body being an absolute master at conserving water.
Okay, so that's the theory. It's a beautiful, logical process. But how do we know it actually happened? Well, the great news is that history left us a ton of clues. We just need to know where to look in life's archives. And the evidence for this incredible story is written, well, it's written everywhere. We can find clues buried in stone as fossils, see surprising similarities in our own bodies, and even find secrets hidden deep inside our genetic code.
The fossil record is like a timeline of life itself. We can see how species have changed over these vast stretches of time. The real treasures, though, are the transitional fossils, like the famous Archaeopteryx. I mean, look at it. It has feathers and wings like a bird, but it also has teeth and a bony tail like a reptile. It's a perfect snapshot of evolution caught in the act.
Then there's the evidence in anatomy.
This stuff is wild. Think about the bones in your arm, a whale's flipper and a bat's wing. They're used for totally different things, grasping, swimming, flying. But if you look at the bone structure, it's the exact same basic blueprint. The only way that makes any sense is if we all inherited that blueprint from a shared common ancestor.
And the clues show up even before we're born. If you look at the early embryos of a fish, a bird, and a human, it's almost impossible to tell them apart. At one stage, human embryos even have structures that look a whole lot like gill slits. It's incredible evidence of a shared genetic toolkit that we all inherited from a common ancestor deep in our past.
All right, so let's bring all these threads together now. We've got variation coming from mutations, which then gets sorted by selection, and that leads to adaptation. So what's the ultimate result of this process playing out over billions of years?
This is really the whole story in 4 steps. It's a dance that never ends. First, random variation provides the options. Second, the environment selects the winners. Third, those winning traits become refined into adaptations. And fourth, over immense geologic time, all those small changes add up and they can lead to the rise of entirely new species.
But there is a flip side to this story of creation. For every single species that succeeds, many, many others fail. When the environment changes too fast and a species just can't keep up, it faces extinction. It's the permanent loss of its unique place in the book of life.
Now, extinction can happen for lots of reasons. Natural climate shifts, a new predator appearing, a devastating disease. But today, one force looms larger than all the others combined: us. Human activity is now accelerating extinction at a truly alarming rate.
And that brings us to a final, pretty profound thought. The theory of evolution shows us that the environment is the ultimate force that shapes life. But our species has become so powerful that we are now changing the entire global environment at a speed nobody's ever seen. We are becoming the primary force of selection on this planet. So the question is, what kind of world are we going to create?